this is an examples video on how to clear or get rid of decimals from linear equations. So this is a follow-up video from my lesson video where I really break down how to do this, but if you're looking for more examples, then you're in the right place. So in this video, I am going to go through, let's see, these 3 examples. You can pause and read them over. If there's a particular one that you want to see, you can just fast forward to that, of course. So without further ado, let's get going. Okay, so the whole idea behind this is that you want to count the maximum number of decimal spots and then move all your decimals that many places. So as I look through this problem, this is 1 spot, this is 2, this is 1 spot, 2 spots, 1 spot. So I need to move everything 2 spots because that's the maximum number of spots. So I'm going to move this 1, 2. I'm going to move this 1, 2. I'm going to move this 1, 2. This 1, 2, and this 1, 2. Okay, so in all of those blank spots, you're going to put a 0 there. So this whole thing will become 10x minus 6 minus 20x minus 4 equals 30. And now from here, you just solve as usual. So this is going to become negative 10x minus 10 equals 30. And then I can add the 10 to each side to get negative 10x equals 40. And I will divide both sides by negative 10 to get x equals negative 4. And then that's it. We're good to go. Okay, so moving on to b here. So this one has a little bit of a twist in it. So as you look through this, I've got 0.3x minus 0.6 plus x minus 0.2 equals 0.6x minus 0.8 plus 0.7. Okay, so the maximum number of decimal spots I see is 1, but here's the plot twist. So I move this one, I move this one. Now, with this x, so remember, you have to move every single part of the problem, all of those decimals. So there's an invisible 1 right here, right? The decimal right here, so I need to move that decimal like that. Does that make sense? I hope it does. If it doesn't, leave me a comment. Okay, so this one I'm going to move over. So I'm moving the rest over just 1 spot like this. So what does this become? This becomes 3x minus 6 plus 10x. This 1x is now 10x because I moved the decimal, minus 2 equals 6x minus 8 plus 7x. Okay, so now I've got 13x minus 8 equals 13x minus 8. And you might already see what the solution is here, but I will finish this out. So I'm going to go ahead and subtract off the 13x like this. And I get negative 8 equals negative 8. And so the interpretation, we've seen this in other videos, this is always true. So this is infinite solutions. Or if you use interval notation, it looks like this. Okay, so see here, so I've got 1 plus 0.2x minus 0.7 plus 2x equals 0.5 minus 0.4x plus 1.8 plus 0.6x. Now I talked about in the lesson video, as you're doing this, you might be fine with decimals to like a certain point. So if you wanted to collect your like terms now, that's totally fine. I'm just kind of trying to show you like the breadth of this technique. But if you have a slightly different way, like you want to collect like terms first, that's totally valid. So just practicing moving decimals. So once again, I have to move everything over 1 spot. So like this 1 has this invisible decimal here. So I'm going to move it over 1, moving all of these over 1. This 2 is going to have a decimal spot moved. So I also like writing this out so I don't forget some of those placeholders. So this becomes 10 plus 2x minus 7 plus 20x equals 5 minus 4x plus 18 plus 6x. Okay, and so now I can collect my like terms. So let's see, that's going to be 3 plus 22x. And then on the other side, let's see, this is going to be 23 plus 2x. So now I've got to get all the x's over to one side and all the numbers to another side. So I always like to do the x's first. So I'll subtract off the 2x. So I get 3 plus 20x equals 23. And then I can subtract off the 3. to get 20x equals 20. Divide both sides by 20 to get x equals 1. And so that'll do it for this particular video. If you were looking for examples that have parentheses in them, I do have a video on that as well, so you can check that out. And if you're looking for a better breakdown on kind of how this works, you can always go back to the lesson video.